Hi, and welcome to session number 7, where we will deep dive into software-defined networking. Before we move on to the lab, let's take a few moments to review some concepts in Neutron. In Neutron, we have the concept of tenant, provider, and external networks. Tenant networks are meant to be private to a given tenant and are generally created by a user or group of users within a tenant. Without a Neutron router, these networks are isolated from one another so that the virtual machines created within these networks cannot route traffic outside of the network. Provider networks are designed to map directly to existing networks in your data center. A good example of a provider network is an existing VLAN-based or physical network within your data center that you would like to incorporate into your OpenStack environment. For example, you may have designated VLAN 20 on a specific subnet for all database traffic, and you might want to deploy database servers in your OpenStack deployment that will explicitly connect this network. A provider network in OpenStack can be either flat, VLAN-based, GRE-based, or VXLAN-based. External networks generally correspond to the physical networks in your data center that are publicly routable and enabled with access to the internet. As an administrator, you would want to supply one or more external networks to Neutron so that your virtual machines can route packets from the internal network to the internet. You can assign floating IPs to your virtual machine and have them publicly addressable from the internet. Routers enable routing of traffic between two or more Neutron networks. A router is capable of routing traffic between Neutron networks of any type, external, provider, and tenant. When a router maps an internal network to an external network, it is sometimes referred to as a gateway. Floating IPs. By default, an instance in OpenStack is created with a fixed IP address. However, an instance can be assigned a floating IP address that can be used to access it over a public network. An instance is identifiable over a public network with a floating IP address. A pool of floating IP addresses can be created, and one floating IP from the pool can be assigned to an instance at a given time. The ML2 plugin is a framework allowing OpenStack networking to simultaneously utilize the variety of Layer 2 networking technologies found in complex real-world data centers. In an OpenStack environment, the Neutron ML2 plugin can be configured to use Open vSwitch as the backend mechanism for managing virtual networking. This means that when you create networks, attach instances, or define routing rules within OpenStack, Neutron communicates with Open vSwitch to provision the necessary networking components. By using Open vSwitch with the Neutron ML2 plugin, you can take advantage of various features such as VLAN tagging, GRE tunneling, VXLAN encapsulation, and more. A flat network is one in which all instances reside on the same network. No VLAN tagging takes place, and Neutron handles the assignment of IPs to instances through DHCP. VLANs are logical networks that may operate a single physical network. A VLAN is a means to logically divide a physical network such that the network traffic on each VLAN is independent of and invisible to the network traffic on another VLAN on the same physical network. VXLAN stands for Virtual Extensible Local Area Network. VXLAN is a virtual overlay network that is built on top of the OSI Model Layer 2 and Layer 3 technologies. VXLAN extends the VLAN address space. VLAN supports the assignment of up to 4,096 VLAN IDs at a time, which may be insufficient for big-scale cloud computing. VXLAN adds a 24-bit segment ID, and hence increases the number of available VLAN IDs to 16 million. GRE stands for Generic Routing Encapsulation. GRE is a protocol that facilitates the delivery of a message payload from one endpoint to another endpoint through a point-to-point virtual tunnel over IP networks. GRE is generally used to encrypt multicast traffic. Lastly, we have the concept of security groups. A security group is a group of rules that apply to inbound and outbound network traffic for an instance. A security group acts as a virtual firewall that controls the inbound and outbound network traffic for the instances to which the group has been assigned. Rules are defined based on what type of network traffic should be allowed to the instance to which the security group is assigned. Traffic that does not match any of the rules assigned to an instance is denied access. A default rule is predefined in the default security group that allows all outbound traffic from the instance to which the security group has been assigned. With that foundation in place, let's move on to the lab exercise, where we will create an external network, create a router, link tenant networks to the router, assign a floating IP to the virtual machine, and then create security groups. So let's dive right in. The first thing we will do is create an external network. To do this, navigate to Networks, and then click Create New Network. The network type should be External Network. We'll give the network a name. For the external network type, we will leave it as flat untagged since I am not using VLANs in this environment. And for physical network, we'll set this to external. Now let's create a subnet. Here is where I will specify the network CIDR address for my external network. IPs from this subnet will be used for floating IPs that can be associated to virtual machines. Click on Create, and now we have our first external network. You'll notice that this is indicated by the external network column here in the UI. Now that I have my external network created, let's move on to creating a router. So let's move on to the router section over here and click New Router. We'll give the router a name, and we'll set the external network to the external network that we just created in the previous step. Now here is where we can optionally attach a tenant network to this router. I'll select the tenant network that we created in a previous session. With all of that in place, I am now equipped to assign a floating IP address to a virtual machine. To do that, hop over to Instances, select an instance, under Network, click on Assign Floating IP. I'll need to create a new floating IP address from the external network that I just created, and we'll map it to the instance that I had selected. Then click on Assign Floating IP. You may notice that now that I've associated a floating IP to this instance, the floating IP address is populated here in the UI. So this is a good segue to the next lab exercise, which is to create security groups. I'm opening up a terminal session here on the right-hand side. And now you'll see when I try to ping the floating IP address, I am unable to. That's because we'll need to create a security group and a security group rule to allow this kind of traffic. To do this, let's navigate to Networks, Security Groups, and let's create a security group specifically to allow ping. We will have to create an inbound security group rule, and I'm going to allow all ICMP traffic for ping. And I'm going to allow traffic from anywhere and create the security group. Let's associate an instance with that security group. Start by selecting the instance, clicking Network, and Edit Security Groups. I'm going to select the security group that I just created and click on Save. As soon as I added the security group, the ping requests were successful.